For this section we have a few different objectives. One is just to be able to find the reference angle for a given angle. We also want to be able to find trig function values using special angles as reference angles, and find angle measures given an interval and a function value. And when we are finding a reference angle, we are really looking at, for an angle theta here in the second quadrant, the reference angle really is how much further to get to 180 degrees. In quadrant 3, for an angle like this, what we're really looking for the reference angle is how far past 180 degrees we've gone. And for an angle that has its terminal side in the fourth quadrant, we're really looking at how much further to 360 degrees. And so that's what we're talking about for reference angles. One important point is that the reference angle is always going to the x-axis. Common mistake is to find the reference angle going to the y-axis, so make sure you don't make that mistake. For our first question here, a 218 degree angle, I would recommend sketching that out to begin with. 218 degrees would be in the third quadrant, and so then the question is how far past 180. So really what we do is 218 minus 180, that gives us 38 degrees. So this angle here is a 38 degree angle, so that's our reference angle for 218 degrees. Second example, we have 1,387 degrees. First of all, we would want to change that so that it's between, or find a coterminal angle really, that's between 0 and 360. So we would subtract from that 1080, and then that would give us the 307. So 307 degree angle, then we can find that that has its terminal side in the fourth quadrant. So we're looking at how much further to get to 360 degrees. So we do 360 minus 307, and we find that the reference angle is a 53 degree angle. Here's a chart summarizing what to do for each quadrant in order to find the reference angle. We'll start here in the first quadrant. The angle and the reference angle are the same in the first quadrant. Moving to the second quadrant, again, it's really looking at how much further to get to 180. So we do 180 minus the theta to find the reference angle. Notice that here they're showing the reference angle with the prime symbol, so theta prime being the reference angle, regular theta just being the angle itself. In quadrant 3, we go past 180. The question then is how far past 180, so theta minus 180. Again, theta would be something like 200. You subtract the 180 from there, you find the reference angle. In quadrant 4, again we go past 270, but the question is how much further to get to 360. So we subtract the theta from 360 to find the reference angle. So for this question we want to find all 6 trig function values for 210 degrees. First thing that we would want to do would be to come up with that reference angle. So 210 would be past 180. We'd be looking at how far past, so we do 210 minus 180. And we come up with a 30 degree angle. So this is 30 degrees. And so that's our reference angle. So reference is 30 degrees. So in order to find the 6 trig function values, I would really need to look at a 30, 60, 90 triangle. Not drawn to scale here, but this is what it would look like, roughly. And again, I've done this a few times lately, so I can remember that that is the square root of 3. Again, we construct that by making an equilateral triangle with all side lengths of 2. We then use the perpendicular bisector for one angle in order to create this 30 degree angle here. That also bisects this side, so if the full length was 2 to begin with, then this side that's been cut in half is 1. We can then use the Pythagorean theorem to find this side here. And this side is still the full side, so that's 2, half of a full side, so 1, Pythagorean theorem to find the square root of 3. From here, finding all 6 trig function values for 210 degrees. One of the other things that we would want to look at is which trig function values would be positive. And so easiest way is to find the two that would be positive. In the third quadrant, we would be looking at tangent and cotangent would be positive because those are based on the x and y values, and x and y are both negative in that quadrant, so the two negatives would cancel out and tangent and cotangent would be positive. The other four trig functions have either an x or a y paired with an r. The r can't be negative, the x or y would be negative, so the other four trig functions would all be negative. So, getting back to finding those trig function values, sine of 210 degrees, again my reference angle is 30 degrees, I know the result should be negative. So from my 30 degrees, the opposite side is 1, the hypotenuse is 2, so negative 1/2 for the sine of 210 degrees. The cosine of 210 degrees, again my reference angle is the 30 degree angle, adjacent side is the square root of 3, hypotenuse is the 2, again cosine would also be negative, so negative square root of 3 over 2. My tangent, again, would be positive because we're in the third quadrant. Reference angle is the 30 degree angle. Tangent is opposite over adjacent, so 1 over the square root of 3. Of course, we can't leave it like that. We would rationalize it and get the square root of 3 over 3. The other trig function values we could find as well. The reciprocal for the sine is the cosecant, so cosecant of 210 degrees, again, would also be negative. Again, my reference angle is the 30 degree angle. Cosecant being the reciprocal of sine would be hypotenuse over opposite, so 2 over 1, so in this case just a negative 2. The reciprocal for the cosine is the secant. Secant of 210 degrees would also be negative. Again, that reference angle is 30, so we would use hypotenuse over adjacent, and then we'd have to rationalize that. We'd get negative 2 square roots of 3 over 3. And then finally, the cotangent of 210 degrees. We would have, again, still that reference angle of 30 degrees, be adjacent over opposite, so square root of 3 over 1. And again, that would be positive because it's the cotangent. We were talking about the third quadrant. Here's a summary for finding trig function values for any non-quadrantal angle theta. So really summarizing what we just did. If theta is greater than 360 or if it's less than 0, then we find a coterminal angle by adding or subtracting 360 as many times as needed to get an angle that's greater than 0 but less than 360. From there we find the reference angle theta, or theta prime really for the reference angle. We find the trig function values for that reference angle theta, and we determine the sines for the values that we found based on, again, which quadrant the reference angle or angle lies in. And so that will give us our trig function values for that angle theta. We'll start here by finding the cosine of negative 240 degrees. So we need to begin by finding a coterminal angle for negative 240. So we add 360 to negative 240, we get 120. So cosine of negative 240 equals exactly cosine of 120. And for the 120 degree angle, we need to find a reference angle for that. So 120 degrees is past 90. The question though is how much further to 180. So we do 180 minus 120. We find that this would be a 60 degree angle. So 60 being our reference angle for this one. Again, I can refer to that same triangle that I constructed on the previous slide. So that 30, 60, 90 triangle, remember the hypotenuse is 2, the shortest side is 1, and we can use the Pythagorean theorem to figure out that the third side is the square root of 3. So finding that cosine, and I would probably determine early on that cosine, since it is in the second quadrant, so cosine of negative 240, which of course is the same as cosine of 120, It's in the second quadrant. Cosine is based on x, and x is negative in the second quadrant, so cosine of negative 240 would be negative. From there, our reference angle was the 60-degree angle. So we'd be looking at adjacent over hypotenuse, so it's just a negative 1/2 for the cosine of negative 240. We'd go through a similar process for the tangent of 675, beginning with finding a coterminal angle for 675. We subtract 360, we get a 315-degree angle. We'd want to find the reference angle for 315 degrees. So if we go 315 degrees, we're in quadrant 4. Question is how much further to get to 360. So we would do 360 minus 315, and of course come up with 45-degree reference angle. So that will require our other special triangle, the 45, 45, 90, which also is isosceles. Again, the way we construct this one is, since it's isosceles, we choose these two legs to be 1. We use the Pythagorean theorem to figure out that the hypotenuse is the square root of 2. So our reference angle is 45, and we are in the fourth quadrant. Tangent would be negative in the fourth quadrant. So tangent of 675 would be negative, and the reference angle again being the 45 degrees. Tangent is opposite over adjacent, and you could really use either of the 45-degree angles because opposite over adjacent either way ends up being 1 over 1. So tangent of 675 is just negative 1. This question just combines a few different trig functions, also some important notation stuff here. We write this as 2 sine squared of 60, but we really do the sine of 60 squared, and then we double it. Likewise, tangent squared of 30, we do tangent of 30, and then we square that. So the sine and tangent won't give us too much trouble because they're already below 90 degrees. The cosine, though, we would have to, again, find the reference angle for 120 degrees. I think we've just done that one, actually. But 120 degrees, again, is in the third quadrant. So the question is how much further to get to 180. So 180 minus 120 gives us 60. So the reference angle for the 120 would be 60 degrees. So I'd use my 30, 60, 90 triangle. Again, once you do this a few times, you kind of get used to it. The hypotenuse is 2, this leg is 1, this is the square root of 3. Cosine of 60 then, being adjacent over hypotenuse, would be 1/2. However, that would be a negative 1/2 because we're in quadrant 2 where the cosine is negative. Cosine would be positive in the first and fourth quadrants because cosine is based on x, and x is positive in the first and fourth quadrants. So cosine of 120 is a negative 1/2. Sine of 60, so I already have my triangle, it would be square root of 3 over 2. So we go plus 2, and then the square root of 3 over 2 squared. Then if we move along to the tangent squared of 30, again, I've got my triangle already. The tangent being opposite over adjacent would be 1 over the square root of 3. Typically, I would probably rationalize that, but we're going to square that anyhow. So I might just leave it as it is for now as 1 over the square root of 3. If we simplify a little bit here as we go, squaring the square root of 3 over 2 gives me 3 over 4, and squaring 1 over the square root of 3 gives me 1/3. Multiply the 3/4 by 2, so negative 1/2, plus, you can write it as 6/4, that's the same as 3/2, minus 1/3. At this point, it's really just some fraction action to figure this out. I would probably take the 1/2 away from the 3/2, that would give me 2/2. So doing this part first, which of course is 1, and then I have 1 minus 1/3. Well, 1 being 3/3, 1 minus 1/3 would equal 2/3. So the value of our expression here really just ends up being 2/3. So here we want to find the cosine of 780. What we'd probably do again is find a coterminal angle, so we would subtract 720 from 780 and we get 60 degrees. So really we want to find the cosine of 60 degrees. Again, they're coterminal, so they have the exact same value. This is in the first quadrant, so it would be a positive value for the cosine. And again, I've drawn this triangle enough times now. I'm getting very good at figuring this out quickly. Cosine of 60 is the adjacent over the hypotenuse, so this would just end up being 1/2. Tangent of negative 405, I'd have to take negative 405 and add 720. And I get 315 degrees. So again, coterminal to 315. I believe we just worked with 315. That ends in the fourth quadrant. And it's another 45 degrees to get to 360. So again, 360 minus the 315 gives me the 45. So I have my 45, 45, 90 triangle, where these are 1 and this is the square root of 2. Tangent would be negative in that quadrant, in the fourth quadrant. So tangent of negative 405 would be negative. And then the opposite over adjacent, again, you could use either 45 degree angle there. Either way, opposite over adjacent is going to be 1 over 1. So in this case, negative 1 because we're in the fourth quadrant. Here we're changing gears a little bit. Given the cosine value, we want to find all the values of theta that are between 0 and 360 that would give us that cosine value. Typically there's going to be two angles that will give us that value. So finding a cosine of negative root 2 over 2, again, you get kind of get used to this. But with the root 2 over 2, that tells me I'm going to have the 45, 45, 90 triangle in order to get that to happen. Cosine being adjacent over hypotenuse would be 1 over the square root of 2, and when you rationalize that, you'd get the square root of 2 over 2. Now cosine, we need this to be negative in this case. Cosine would be negative in the first and fourth quadrant, or sorry, change that. Cosine is negative in the second and third quadrants, because that's where x is less than 0, and cosine is based on the x values. So we'd be looking at reference angles of 45 degrees in the second and third quadrants. So if this is 45 degrees here, that means we're 45 degrees short of 180. So 180 minus 45 would give us our reference angle that we would want. That would end up being a 135 degree angle. And if we have a 45 degree angle in the third quadrant, that means we are 45 degrees past 180. And so that ends up giving us our reference angle of 225 degrees. So those are the two angles between 0 and 360 that would give us a cosine of negative square root of 2 over 2. And thank you for watching this video. Here is some practice that you could use. Again, several of these values are already filled in, but just finding the 6 trig function values for these angles, 30, 45, 60, 120, 135, 150, 210, and 240. Again, all of these will be our either a 30, 45, or 60 degree reference angle. So you want to have your special triangles handy, and may want to even go through first and determine which of the trig function values would be positive and negative. You can just fill in those negatives where they might happen. Again, remembering that outside of the first quadrant, each of the other quadrants, 2, 3, and 4, there are only 2 trig functions with positive values in them. So good luck with that.